Welcome back to the Portland Technical YouTube channel. Hope you're having a good day. In this video, we're going to be taking a look at using a milliohm meter. Milliohm meters are used for hybrid electrical motor diagnosis. So, hybrid trained technicians only should be using this tool. Let's get into it. First of all, what is a milliohm meter? Well, when it comes to a conventional digital multimeter, it cannot measure the small resistance value that verify that electrical connections are clean and properly tightened. So in other words, a milliohm meter is a precision instrument used to measure resistance between the interphase windings of our electric hybrid motors. Now, there's certain DTCs that require that continuity and integrity of wires, cables, or windings be measured with extremely accurate milliohm meters. Or in other words, typically a milliohm meter is used to measure resistances accurately when the specification is less than 1 ohm. So, in other words, 1 milliohm equals 1,000th of an ohm. Or in other words, 1 milliohm equals 0.001 ohms. So very small resistance values. In simple terms, a milliohm meter is for checking high resistance. That's it. Nothing complicated. It's just measuring for high resistance. It just so happens that high resistances will be less than 1 ohm. In fact, this meter is so accurate, if the motor generator cable temperature is high, the resistance will vary significantly from the specification. So be sure to measure the resistance at least 8 hours after ready off. Note, the repair manual specifications are based on 68 degrees Fahrenheit. In fact, this is so accurate and so picky that if temperature is different, the resistance has to be calculated. Huh? How do we do that? Well, let's take a look at the milliohm meter itself. This will give you a better understanding. This is our milliohm meter. It can be found in the red toolboxes and supplied by Toyota. Made by Hyoki, this is the tool itself. Looks complicated, but it's not that bad. The leads that go to it is going to be positive and negative, just like any multimeter. And then here's where it connects to the meter itself. Now, because temperature has to be corrected, there is a temperature sensor that will fit on the meter to go ahead and correct it for us automatically. Let's take a look at how to connect the leads to the meter. Now, notice that for both positive and negative, there is both a sense and a source connection to our leads. Both positive and negative are indicated by this arrow for sense, and there's going to be correlating arrows that are on the leads. So here's the leads, there's the positive, and you can see the arrow right there. So I'm going to plug it in so that those arrows will match up. Okay, there's the positive lead. Notice there's the arrow on the negative lead. That way we make sure that sense and source are connected properly. And that's it. Let's go to the temperature sensor. So on the top of the meter itself, this is where we plug in our 1/8 inch adapter right into the temperature port. Just that simple. Now it will correct it for us. Okay, so let's go ahead and use the milliohm meter in a situation. I'm on TIS right now, and I'm going to go ahead and take a Camry HV 2010. And the scenario is that when the vehicle came in, check engine light was on, and stored in memory is a P0A1B. Okay, search, and it just so happens that our info code is a 788. So let's find that DTC. There it is right there. Maximize it here, and I'm going to get rid of our tree. Okay, so in this situation, we've had an error in reset signal from the power source IC. And we can see our trouble areas, and it looks like it can be components like the MG-ECU or the hybrid transaxle, or it could be wire, harness, or connectors. So I'm going to make this quick here and go through the steps. First of all, we're going to have to safe the vehicle. In other words, disconnect the negative battery cable on the aux battery, pull the service plug, wait for 10 minutes for all of the power to dissipate from the capacitors in the inverter assembly, and check my gloves, everything that's necessary to go ahead and safe the vehicle. Now, after I've verified that there is 0 volts in the inverter itself, I'm going to start with my procedure. First of all, they say check DTC output. We know that we have the P0A1B with the info code of 788. So no, it wasn't communication codes involved with it. So we're going to go down to step number 2. They say to check the connectors on the inverter and converter assembly, mostly for the MG, ECU, and so forth. We're going to say that it's okay. They say to go ahead and check the harness in the engine room on the opposite end, in particular for this relay, this IGCT relay. We'll say that all is good, all is good, all is good. Get down to step number 4, and now they're saying to go ahead and check the motor cable that's there on the inverter and converter assembly. And let's say that it's tightened properly and everything looks okay that way. So now the process is going to go ahead and to remove those cables and actually check the transaxle assembly itself. And what do they say to use? We're going to use our beloved milliohm meter, as you can see right there in C. So we're going to measure between the 3 windings of the motor generators themselves. So in other words, between U and V, V and W, and W and U. And let's take a look at the specifications. Wow, look at that. 59 to 65 milliohms. That's only 6 milliohms as possible good measurement. Pretty much the same with V and W and U as well. So we're looking for a very small window of resistance, which, by the way, converted this to ohms, 59 to 65, that would be 0.0059, excuse me, 0.059 to 0.065. That is our window for a good measurement. Now, the repair manual gives an equation to go ahead and correct for temperature because, like we said before, it's based on the temperature being 68 degrees Fahrenheit. So, luckily we've got our nice Hioki milliohm meter that is going to correct temperature for us, so we don't need to worry about that. So, now that we have our specification, let's do our actual measurements. Let's turn the meter on and see our screen. It's going to give a second to calibrate. Okay, let's look at the major parts. First of all, there's going to be a range. Now I'm in a manual range, but there's auto, and that should be used. Here it shows our temperature in Celsius, and then also shows our resistance readings. We are temperature corrected, that's the TC that's on top. Okay, let's do our measurements. Okay, so we have our insulated gloves that have been tested previously. I'm going to slip these on. And our first measurement is going to be between U and V, then V and W and U. So here's my leads, red for positive, black for negative. I'm going to put red or black, doesn't matter, on U, and then the other on V. Specification was 59 to 64. We're reading 63.78. That's good. Here is V and W, it should be 56 to 62. Looks good. And then W and U, which should be 56 to 62. Looks good there. Okay, so I have verified that my connections on U, V, and W are all good. Okay, so let's summarize our activity here. First of all, reminder, only hybrid trained technicians should be working on high voltage systems. Also, the milliohm meter is for measuring high resistances. Now, what's considered high resistance in this situation is less than 1 ohm. Remember, the specification is at 68 degrees Fahrenheit, so let the vehicle sit for 8 hours before doing your measurements. And if resistance is out of specification, what should we do? We should clean the accessible connections and retest before condemning any components. That's it. That is the milliohm meter. Thanks for your time.